Hello everyone. In the last session, we are discussing about fundamental theorem of arithmetic. That is, every composite number can be expressed as a product of primes and this composition is unique. This is called prime factorization or canonical representation. We also studied that the sum of all positive divisors of a number that is equal to S of n is equal to p1 to the power of alpha 1 plus 1 minus 1 divided by p1 minus 1 into p to the power of alpha 2 plus 1 minus 1 divided by p2 minus 1 into so on up to pn to the power of alpha n plus 1 minus 1 divided by pn minus 1, where p1, p2, pn are prime numbers and alpha 1, alpha 2 are perverts. And we also studied that the number of positive divisors of a number t of n is equal to 1 plus alpha 1 into 1 plus alpha 2 and so on up to 1 plus alpha n. In this session, I am going to solve few problems. Find the number of divisors and sum of the positive divisors of the following. In that, first one is 825. Given that 825 is given, we have to factorize by prime factor. 8 to 25 we have to divide by prime numbers. That is, we know that first prime number is 2 and 825 is not divided by 2, so I will divide by 3. 3 2s are 6, 1 is 2 is remaining, 3 7s are and 3 5s are. 275, which is divided, we can divide by 5. 5 5s are 25, 2 is remaining, 5 5s are 25. And 55 also divided by 5, 5 1s are 5 1s are. And 11 is divided by 11 only, 11 1s are 11. So 825 can be represented as 3 into 5 into 5 into 11, 3 into 5 into 5 into 11, 3 into 5 into 5, 5 square and 11. Here P1 is 3, P2 is 5 and P3 is 11. And alpha 1, 3 to the power of 3 to the power is 1, so alpha 1 is equal to 1 and alpha 2 is equal to 2 and alpha 3 is equal to 1. We know that formula T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. 1 plus alpha 1 is given that 1 and alpha 2 is 2 and alpha 3 is 1. So 1 plus 1, 1 plus 2 and 1 plus 3. 1 plus 1 is 2 into 1 plus 2 is 3 and into 1 plus 1 is 2. 2 into 3 into 2. 2 3s are 6 and 6 2s are 12. T of n is equal to 12. Like this, we know that the formula that S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P to the power of alpha 2 plus 1 minus divided 1 divided by P2 minus 1 into P to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. I will stop up to P3 because we have only 3 factors, so I will stop up to P3. In that formula, we know that is up to n factors. So 3 to the power of 2, P1 is 3, 3 to the power of 2, y2 is 1, alpha to the power of 1 is 1, 1 plus 1 is 2, minus 1 divided by 3 minus 1 into 5 to the power of 2 plus 1, 5 to the power of 2 plus alpha 2 is 2 plus 1 minus 1 divided by 5 minus 1 into alpha 3, P3 is 11 and alpha 3 is 1, alpha 3 plus 1 is 1 plus 1 is 2 minus 1 divided by 11 minus 1. 3 to the power of 2, 3 to the power of 2 means 9, 9 minus 1, 8 divided by 3 minus 1, that is equal to 2. 5 to the power of 3, 5 to the power of 3 means 125, 125 minus 1, that is equal to 124 divided by 5 minus 1 is 4. 11 to the power of 2, 11 to the power of 2 means 121, 121 minus 1, that is equal to 120 divided by 11 minus 1 is 10. 2 ones are 2 fours are, and 4 ones are, and 4 31s are, and 10 ones are 10 12s. 4 into 31 into 12, that is equal to, if we simplify, we get 1488. The sum of all positive divisors is 1488. Next problem, 960. Take 960. We know that we have to divide from prime factors. That is, we can divide by first prime one, that is equal to 2. 2 4s are 8, and 2 8s are 16, and 0. 480 also divide by 2, that is equal to 2 2s are 2 4s are, and 0. This also divide by 2, and that is equal to 2 1s are 2 2s are, and 0. And this also divided by 2, that is 2 60s are 120, that is 2. This also 60 is also divided by 2, that is 2 30s are, and this one is also divided by 2, that is 2 15s are 30, and 15 is divided by 3, 3 5s are 15, and 5 is divided by 5. So 960 can be represented as 2 into 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 3 into 5. That is 2 1 2 3 4 5 6. 6 times is 2 is there though, so 2 to the power of 6 into 3 into 5. So we can easily find P1 is equal to 2, and P2 is equal to 3, and P3 is equal to 5. Similarly, alpha 1 is equal to 2 to the power of 6 is there, so alpha 1 is 6. Alpha 2 is equal to 3 to the power of 1 is there, so alpha 2 is equal to 1, and alpha 3 is equal to 5. We can find T of n, that is equal to, you know that 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3, that is equal to 1 plus 6 into 1 plus 1 into 1 plus, so sorry, here alpha 3 is equal to 5 to the power of 1, that is equal to 1. So 1, this is equal to 7 into 2 into 2, that is equal to 7 2s are 14, 14 2s are 28. Similarly, we can find S of n. We know that formula, that is P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. That is equal to 2 to the power of alpha 1 is 6, 6 plus 1 7 minus 1 divided by 2 minus 1 into 3 to the power of alpha 2 is 1, 1 plus 1 is 2 minus 1 divided by 3 minus 1 into 5 to the power of 2 minus 1 divided by 5 minus 1. 2 to the power of 7 is 128, 128 minus 1 is 127 by 1, 2 to minus 1 is 1, and 3 square means 9, 9 minus 1 is 8, 8 by 2, and 5 square means 25. 25 minus 1 is 24 by 4 minus 2. 5 minus 1 is 4. 127, and 2 ones are 2 fours are, and 4 ones are 4 six are. That is equal to 127 into 4 into 6. That is equal to 3048. S of n is equal to 3048.